I don't know about accomplished pie baker, maybe like accomplished pie eater. Anyways, I know it's 4 p.m. on a Friday. I'm glad you're here. Thank you for having me. We'll try and keep this pretty lively. So my name is Eben. I work at a company called Honeycomb. I think we do some pretty cool stuff, but I'm not here to sell you Honeycomb today. I'm also not here to carefully define the word observability and argue at length about observability versus monitoring, or to talk about problems of observability at very large scale, or like intrinsically technically challenging instrumentation problems, like problems that you might have in very high performance or very low level systems. Like, I think we can all empathize with James Mickens' predicament, but like, I know I certainly do. But this is not exactly the problem that I want to talk about today. Instead, what I want to talk about is what I think is a pretty high leverage approach to improving observability within the context of your own organization, both based on my own professional experiences, like running software systems, and helping a lot of our customers at Honeycomb do the same for their own services. So to set the context, I assume that you work on a software product that has users, and that you care about those users, like maybe not a lot, but at least you care a little bit about their experience. And also that, this is a DevOps conference, so assume that you write services and run them in production. So the things I want to talk about primarily apply when you are actually writing code yourself. If you're primarily concerned with operating databases or Kafka or something like that, that's an interesting topic, but a little bit of a different one than what I want to talk about. And finally, I assume that it's valuable to you to understand what's actually going on in production, maybe for a variety of different reasons. Maybe everything is like on fire all the time, and you need to diagnose like US East 1 is, I don't know, having a bad day or something. Maybe you primarily want to understand what your users are doing or not doing with your product so that you can make business decisions or prioritize features. Maybe you're rolling out code and you want to measure the effect of changes on the performance of your system, on your users' behavior. Maybe you want to just poke around and see if you can generally make things better in some way, make things faster or cheaper or more user-friendly. So this is roughly what I mean when I talk about observability, answering these sorts of questions, all sorts of questions about what's happening in production. All right, how do we do this? I think this will come to no surprise as anyone. You instrument your code, emit data, you send it somewhere, and you retain it so that you can ask questions. Concretely, this might mean that you have logs, metrics, or traces in your code. You use some sort of transport layer to send that data to some storage and retrieval system. How many people here use any one of these technologies in their daily work? Cool. How many people use one of these technologies and yet either say or hear their colleagues say something like this? Wow, there are all these errors and exceptions, and I don't have enough context to figure out why they happened or who's affected. We have all of these metrics that someone else invented, but I don't really know what any of them mean. I want to try out this cool new tool I read about on the internet, but it's going to be like a big project just to get it integrated with our services. I'm writing this new feature, and I know I should really be instrumenting it, but I don't really have a good handle on what will be actually useful, like where I should put the logs and what I should put in them. Familiar predicaments? Certainly familiar to me. The good news is these are essentially cultural problems, right? Not intrinsically hard, intractable problems in computer science. I think a productive way to think about this is, a lot of instrumentation tends to evolve pretty ad hoc. You start with a prototype, you throw some print statements in, it somehow makes its way into production, you like add metrics after things break, and maybe you end up with something that kind of looks like this. So my thesis is that there's a missing layer in the picture of the stack that we presented before, a library of patterns that you can develop at your organization to help everyone better instrument code. I think generally mature organizations tend to develop their own instrumentation library and API that they use internally. This is a way, if done well, to encourage effective practices and make it easier for everyone to write observable software. Done properly, this is a way of using code, like using computers, to help solve essentially a cultural problem, a communication problem, which I think is pretty compelling. And this is also high leverage work. you're not just going and fixing all the log statements yourself. You're providing a blueprint for others to follow. You're capturing the collective knowledge of your organization, ensuring that instrumentation captures useful context, and making it easier to incrementally improve things over time if you invest in this idea of a baseline instrumentation library for your company. Whoa, whoa, whoa. I read about like these cool things on Hacker News that should solve this problem for me, right? Like open tracing, open census, Stripes Veneur, whatever. Shouldn't they be the instrumentation libraries that I'm using? I would argue yes, to a point. Your job, or at least my job, is to solve business problems for my company, not try and solve like the software problems of the world. It's generally easier, more economical, and more efficient to adopt and evolve an API that solves your problems, not the problems that the authors of these libraries envisioned. You may find it useful to integrate and adapt some of the ideas from these frameworks to solve your problems, make your life easier. But it's better to invest in developing an API that works for you rather than trying to shoehorn someone else's into your own infrastructure. And I think this has analogies in other parts of the software system. Like, you probably haven't written your own database, maybe, I hope, like, I don't know, unless you have a very good reason. But you probably have your own database schema. Maybe you didn't write your own HTTP framework, but you have your own HTTP library. You know, again, hopefully you didn't write your own JavaScript framework. I don't know. But you do have your own UI, right? And what you build on top of these foundations embodies what matters to you: the data model, the service model, the visual style. And so doing this is work that deserves thought and attention. And I think the same idea applies to instrumentation. Take foundational technologies, logs, metrics, tracing, build a layer on top of them that solves your problems. So this is a lot of thought leadering, but I want to get real and sort of give concrete examples of things that we have seen, like very small and non-invasive changes that you can do in this direction to make your life easier. So let's sketch the outline of such a library. Talk about how you can start with structure, add context, encourage people to explain themselves, hide tedious transport details, and finally embrace pragmatism, like focused on solving real problems, not gratuitously hard problems. And we'll do this in less than 10 lines of code for each of these things. All right, everyone on board? Cool. So common problem. We have this like dumpster fire of logs. The customer complains about something, and we can't even figure out where to start looking. Step one, ditch your strings. Try to ensure that the data you emit is self-describing. You know, a typical web server format string is relatively opaque. It's hard to decipher unless you know what each field means. It's hard to change. It's hard to extend. Like, what's the second dash? Like, I have no idea. I want to add a new thing. Do I add a fourth dash? Who knows? Like, in contrast, the same data encoded in some sort of self-describing format is much easier to look at and extend. Like, maybe I've never heard of Nginx, but like, I can look at this JSON blob and pretty easily figure out what it describes. If I want to add something else, like a user ID or a header value, it's pretty easy to do that. What does this mean in code? It means that it's a good idea to avoid like directly formatting your logging strings with like printf statements. The first thing I do in a new code base is like you can go in and grep for like log statements that contain percent format specifiers. These are anti-patterns. Again, they're difficult to aggregate, they're difficult to search, they're difficult to extend. Instead, you can make it easy to emit structured data. So let's say we have an instrumentation library API, we'll call it baseline. Instead of like constructing some format string, we write something like baseline.log, and we specify key value pairs. Maybe we can implement this like this. Check out my library. This is amazing. Like, I'm going to be an open source hero, right, with my 5 lines of code. Like, but like, I don't know, this might seem silly, but I think there's an important point hiding in this API, which is that structured logs are now the default way to emit log statements. Like, if I'm using this library, I am encouraged to specify key value pairs instead of some ad hoc format string that I thought would be a useful way of representing the data at the time. Make sense? Cool. This also helps us add context. Like, how many people have been on call and said these very words? At least one person. So I get some error, stack trace log message. I don't have enough context to figure out the sequence of events that led to this happening. Who is affected? Is it some systemic problem? Is it a user doing something weird? Is it AWS? Without adequate context, it's very difficult to take some random log statement and figure out what it really means. In general, attaching additional context is cheap. Not having that context when you want to go solve real problems is expensive. Context might include things like customer IDs, user IDs, builder version numbers, request IDs, feature flag sets, function name, line number, AWS region, I don't know. Anything that you can think of that makes it easier for you to slice and dice all of the data that you're collecting to understand what's going on. Fortunately, a lot of this can be automated. Context can be scoped to a process, a function, or a request, depending on what it means. A very crude, simple example of attaching context is process scoped context. What environment am I in, like development, staging, production, and what version of the software am I running? All right, we can take our 3-line library and make it a 7-line library or whatever by including this additional context. You might be like, this is stupid, but I actually don't think it's stupid. I think it's a useful thing to do. We did this when we were migrating some services to Kubernetes. With a 1-line change, we were able to attach an infra type field to all of the telemetry that we were emitting from a dozen different services or whatever. So this is useful during the migration. We can diff EC2 metrics against Kubernetes metrics and see if there are performance regressions with a 1-line change. Imagine taking 500 log statements across your application and going and adding this all by hand. Big pain. Secondly, it's useful to make it easy to incrementally build up context, to think in events which map to a unit of work rather than individual log statements. So I have a method. At the beginning, I create an event. As I accumulate context, as I go through the process of executing a method, I incrementally attach context. What API endpoint am I hitting? What user do I have? And so on. At the end, I dispatch it. Again, this is pretty easy to implement with a couple lines of code, but it opens up some interesting possibilities. What if you automatically time this duration? Now you have, instead of just log metrics, which might or might not include timing information, now you have performance metrics in a pretty consistent way throughout all of your service, and it's completely hidden, no boilerplate. Pretty good, if you ask me. Next problem. We have all of these crazy metrics that someone cooked up, and I just joined, and I have no clue what any of them mean. What is this? I don't know. Can we solve this problem with code? Maybe. What if we make people attach a help string whenever they attach context to an event? Maybe in your organization, everyone understands what all of the metrics that have been created over the 6 years of the company mean. Maybe they don't. Maybe this is a tractable way to use an API to encourage self-documenting code, right? There are different things you could do with this. Maybe your tools support it, and you can send these when you first submit an event, or you just treat it as documentation. Whatever, it doesn't really matter as long as you're helping your team be more effective. Finally, I think it's useful to abstract away some transport details. You probably have multiple tools for logs, metrics, exceptions, traces, whatever. It's pretty painful to go in and explicitly add instrumentation for each of these things in every single place in your code site. It's a good idea to abstract away the protocol details behind a common layer. This also helps you address common objections. Wow, I structured my logs. Now they're in JSON. And your teammates are like, I'm trying to develop, and I can't read this. There are, I think, 2 reasonable responses to this. One is shut up and deal with it. We're doing structured logging because we're cool, so you must suffer. The other is, can we help you with this problem? Well, yes, it's actually quite tractable to output JSON in a production environment, and then maybe pretty print your logs in development. So instead of alienating your teammates, you can use code to sort of support the use cases that they actually come to you with. Seem fair? I don't know. I don't like telling people that they have to eat their vegetables. And finally, really the theme here is that I think it's worthwhile to embrace pragmatism. How many of you have had this problem? Wow, something went wrong, and there's debug logging, and guess what? We don't have debug logging in production because we don't have bugs in production, right? No. OK, so what can we do about this? We can treat this as a really hard problem and emit ludicrous amounts of instrumentation all the time and try to hang on to it. We can try to be really smart about when we emit debug logging and when we don't. Or we can do something extremely crude and yet pretty effective. Like, OK, for most of my events, I won't emit debug logs. And for 1 in 1,000, I will. Seems pretty dumb. Like, this is not what I went to school in computer science for. But it works, right? Like, any problem that affects more than 0.1% of requests will have debug logs that you can look at. And we did this in 3 lines of code, half an hour. You know, I don't know. That seems pretty useful, I guess. I don't know. You could do worse. Like, you could spend many months working on some very advanced solution to this problem. And maybe eventually it's worthwhile to do that. But why not start with something relatively simple? Other ideas. Safeguards. Make sure that transport doesn't block the critical path. Like, accidentally, someone writes ludicrously large logs or puts instrumentation in some super tight loop and crushes your infrastructure. You know, maybe you can implement guardrails in code that prevent this from happening. Maybe you can unit test your instrumentation. You know, if you have a strong culture of unit testing, that's great. Often what happens is it's kind of hard to test that your instrumentation actually behaves the way it does. You ship your code and you go look at the graphs, and either the graphs look right or the graphs look wrong. But the library makes it tractable to write tests for your instrumentation and ensure that if you change your code, the instrumentation keeps up. Again, not bad. Helps you ship faster, helps you ship with more confidence. So to summarize the key points here, every one of these ideas is an incremental improvement. You can prototype it in just a few lines of code. It doesn't have to be a multi-month project. You don't have to pay a vendor a lot of money. I mean, I'm stoked if you want to pay us a lot of money. I work at a vendor, but you know, that's kind of an orthogonal problem. You get to choose the pain points to prioritize. You can make small changes that have a large team impact by focusing on nurturing this baseline of observability in your organization through code. So again, invest in instrumenting. 5 ideas: structure, context, explanation, abstraction, pragmatism. Focus on the problems that matter to you. Solicit feedback from your teammates. That's all I have. Thank you very much.